Hi students, welcome to my lectures on chemical reaction engineering. Majority of the times in my previous lectures we have discussed about the elementary reactions, right. From the beginning most of the part we have deal with the all the kinetics of different reactions, and almost all the reactions are elementary reactions. And in the today's lecture we have to discuss that how to deal with the kinetics of non-elementary reactions, because when we move forward into the lectures, majority of the industrial reactions are of non-elementary in nature. So, let us discuss that how different people dealt with the non-elementary reactions. Today our objective is to know about the non-elementary reactions and how we have to deal to get the rate expression, because it is not simple KCA. RA minus RA is equal to minus dCA by dt is equal to simple KCA is the first order, KCA square is the second order, K is the 0 order, and we have to deal because there are different kinds of non-elementary reactions exist and we have to deal with them on a simple basis. And let us get one how to get one common procedure to get the rate expression. In today's lecture you are going to get to know about the pseudo steady state hypothesis. Okay. Normally this is the hypothesis we have to apply to get the rate expression in case of non-elementary reactions. If you remember, let us go into the lecture. If you remember, the elementary reactions looks this way. If A plus B gives rise to C, then RA minus RA is equal to minus dCA by dt into K into Ca power 1 and Cb power 1, which is matching with that of a stoichiometric coefficients of A and B. If this is the case, and it is very simple to deal with, we can write a simple rate expression and we can use it for different purpose. But in today's lecture we should talk about dealing with the non-elementary reactions. For example, if stoichiometric coefficients. So, if you see these kind of equations, then you can presume that okay, this equation, the reaction will not happen in a single step, there might be multiple steps. Because of that multiple steps you get this kind of weird rate expression which cannot be correlated to the stoichiometric coefficients. And first assumption, in cases, by looking at the equation, looking at the expression, you can able to find out whether this is elementary or non-elementary. And if it is a non-elementary, there is no single reaction, there are multiple reactions takes place, because it is not simple A plus B gives nothing but intermediates. Okay. If the intermediate compounds are there, this intermediate compounds react to form the final product which is C. This is non-elementary reaction is the summation. It is not happens in a single step, it is a number of elementary steps are there. One non-elementary step is a combination of number of elementary steps. In this number of elementary steps we have to find out which one is our reactant, which one is our product, which one is our intermediates, we have to identify. Based on that we can able to get the final rate expression by applying the concept called pseudo steady state hypothesis. Primarily it applies for this kind of non-elementary reactions. Okay. Let us deal with this. First let us know what is the non-elementary. And as I discussed, the non-elementary reactions, it won't happen in a single step, multiple steps are there. In multiple steps there are intermediates that exist. Intermediates are the compounds which temporarily form during the reaction, and finally it will get consumed in the reaction to get the product. So, what kind of intermediate, what are the different reactions, in those different non-elementary reactions, what are the different kinds of intermediate compounds that are present, because the life of the intermediate is 0. That means it won't stay there for longer period of time. It will form, it will immediately react to form product. Okay, these are called the intermediates. And in number of reactions are there in the chemical reaction engineering. How I can differentiate the intermediates? The intermediates could be free radicals. Free radicals, I mean H2 gives rise to 2H dot. I mean this dot symbol wherever you see, those are called intermediates. They are highly reactive because there are it is a fall short of kind of electrons or so. So during the formation, it is immediately get reacted to form the product or some other compound. So free radicals are those which fall short of electrons, H dot, CH3 dot, these are called the intermediates. And the another intermediates we will see is called ionic intermediates, Na plus, Cl minus, OH minus, they are also reactive. In the reaction it will form and it will immediately react with another molecule to form a neutral molecules. So that these are called intermediates such as ionic intermediates. Molecules, A gives rise to R gives rise to S. R is a molecule, okay, unstable molecule. What happens, first A will react to form R. This R, because it is an intermediate, it is highly reactive, immediately R will become S. Okay, wherever, because during the reaction you can't able to find out this R frequently, because it will immediately form and it immediately form S. Okay, the life of R is very short. If you are, because there are number of sophisticated techniques are there to find out the intermediates, because within a fraction of second it will form and it will decompose. So molecules. Transition complexes, normally what happens, it is a highly energized molecules, because A and B collide and it will reach to a certain state where we can exchange of energies will takes place between A and B. Those are called transition molecules. This transition complex is very unstable, immediately sometimes it forms the product and sometimes it will come back to form A plus B again. Okay, few reactions are the forward reactions, few reactions are reversible reaction, that means forward reaction, backward reaction, both reactions takes place in all the contexts we are discussing about. So broadly, if you classify the intermediates, these are the 4 intermediates. Okay, then if you talk about non-elementary reactions, these intermediates will form. And we can classify the non-elementary reactions into 2 broad classifications. One is non-chain reactions and second is chain reactions. Whether it is a non-chain reactions or a chain reaction, the intermediate will form. Okay, but the life of the intermediate is very short. These are the things you have to keep it in your mind. Okay, what are the non-chain reactions? Simply the reactants, they will try to collide each other to form an intermediate. This intermediate in the second step is going to form the products. Both are reversible reactions. It could be reversible or it could be irreversible, but because once the intermediate forms, it is highly possible that this intermediate will come back to the reactants and this intermediate will go to the product. Okay, and the product come back to the intermediate. Everything is reversible, few are irreversible. So that is where the reactants will form intermediates and this intermediates further to form the products. Okay, it is very 2-step process. Okay, this is called non-chain reactions. And for example, for the non-chain reactions are azomethane, okay, gives rise to ethane plus nitrogen. And that if you look at the rate expression, the rate expression looks like the decomposition of azomethane which is equal to the formation of nitrogen, which is equal to the, because for the reactants we take a negative, for the products we take positive, then that is nothing but K1 K3 into Ca square by K3 plus K2 into Ca. Ca is nothing but azomethane, because I have given A to azomethane, B to ethane plus C to nitrogen. Okay, and this we have to get somehow because you can, by looking at the equation itself you can able to judge whether it's elementary is non-elementary, because there is nothing a stoichiometric coefficients is matching with the within the rate expression. So This is one kind of non-chain reactions. The same non-elementary reactions can be chain reactions. What happens with the chain reactions? First, the reactants will form the intermediates, right? Then this intermediate will not form, directly cannot form the product. This intermediates will again react with reactants and form the product, as well as again one more intermediate is forming here. See the intermediates which is reacting with the reactants to form the products plus some more intermediates here, and this intermediates is directly forming the product. Okay, there is no another intermediate that is forming after the product. Here the chain reactions, this intermediates will be going to get reacted with reactants, and this reactants product plus some more intermediate. Here the more intermediates is going to form along with the formation of the product. Here there is no intermediate that is forming after the formation of the product. This is the only difference between the non-chain reactions and chain reactions. And if you there are few steps in the non-chain reactions. First of all, reactants which is collide among themselves to form the intermediate. The formation of intermediates, which is a reason for the formation of product, that is why it is called the chain initiation reaction. And second step is the chain propagation reaction. This intermediate will react with reactants to form the product plus some more intermediates. You can see, and this chain continues because one intermediate is reacting with reactants to form the product plus some more intermediate. That means this intermediate is going to get reacted with another reactant to form the product and some more intermediates. So because it is chain is getting, that means the reaction is getting propagated, right? That is why it's called the propagation reaction. And here the intermediates, okay, intermediate and the another intermediate collided to form, this is called termination reaction, because this intermediate finally forming the product and no more intermediate that is forming. So if this such kind of things are there, that is called the termination reactions. Okay, then if you divide the chain reactions into three steps, one is initiation step, second is propagation step, third is termination step. Let us see what are the, with an example. Okay, hydrogen plus bromine gives rise to 2HBr. And you can see the rate of HBr, it is nothing but 2 times the rate of hydrogen, because the stoichiometry is that way. And positive for the product and negative for the reactant, nothing but K1 into CH2 into Br2 power half divided by K2 plus CHBr into Cbr2. Now you can see there is no stoichiometric coefficient of hydrogen is 1 and bromine is 1 and HBr is 2, and you can see here there is the concentration power 1. It is power half, it is power 1, this is power 1. There is nothing you can relate with the stoichiometry of the reaction. If that is the case, that means it is a non-elementary reaction, and we have to assume one mechanism, because valid mechanism is there, and let us see what is this. Okay, people come up with this rate expression by assuming this kind of steps. Okay, the steps will be validated with the experiments also. First, the bromine will become an intermediate which is called free radical intermediate. Br2 is becoming 2 into Br dot. That means 2 bromine intermediates are there. Because the intermediates are forming here, that is called this initiation step. Let us see propagation. Okay, this intermediate which got generated because of this initiation step react with hydrogen to form HBr product plus some more intermediate. You can see wherever you see more intermediates are getting generated because of that reaction, then that reaction is called propagation reaction. H dot, this H dot, because whatever has been generated here reacted with normal bromine molecule, with here it is hydrogen is getting reacted with the intermediate Br dot. Here this intermediate hydrogen reacting with the bromine molecule Br2 and form product plus some more intermediate. You can see in these two reactions more intermediates are getting generated. Here our intermediates are Br dot and H dot, both are our intermediates. In whichever may be the reaction, the intermediates are getting generated along with the product, then the steps are called propagation steps. Then finally 2Br, okay, 2 intermediates of bromine molecule gives rise to Br2. That means now these 2 bromine molecules will become a normal molecule, and you can see the intermediate is becoming normal molecule. That means intermediates are getting short in the reaction because of this. That is what it's called termination reaction. So because of termination, as long as Br dot is there, H dot will get generated. So once you consume the Br dot in the reaction, automatically Hr dot will get will get stopped. So that is why the last step, which is the this intermediate is getting a normal molecule, is called termination reaction. Now you should understand what is the initiation reaction, what is propagation reaction, what is termination reaction in the non-chain reactions. Here reactants to form intermediates directly it will become a products. Here there is no propagation of the reaction, okay. Here simple intermediate is getting become products, right. Once an example is the hydrogen and bromine. Here is example of the azomethane. Then okay, I have certain mechanism I have, because initially what happens to in the non-chain mechanisms, how the people will assume the mechanism. First they think that okay, whenever there is no match between the stoichiometry and the rate of reaction, first they will assume some reaction. Maybe one molecule of azomethane is colliding with another molecule of azomethane to form one active azomethane, one normal azomethane, because energy energy exchange will takes place, right. One molecule of azomethane is in the active state and one molecule is in the normal state, and this active molecule and react with normal molecule again to become, because this is a reverse reaction, because one is a two normal molecules will become one active, one normal. This one active, one normal will come back to the normal state, which is two normal molecules of azomethane. And the another step is finally one of this active molecule will become product, which is ethane and nitrogen, B and C. Normally first they these both are reversible reactions. This is a normal forward reaction they have assumed. Based on this they come up with some rate expression. So let us see in the next lecture how they have got this rate expression. I will do that. They will assume they will get one rate expression, they will conduct some experiments, speed or rate experiments. If that rate is matching with it of a whatever the mechanism we have assumed, then these are the actual steps that is happening. Similarly here also they will conduct some experiments. Finally the experimental rates and this theoretical rate, by assuming this kind of mechanisms is matching, then these are the valid steps. If they are not matching, they will assume some more mechanism, and finally they get different rate expression. That different rate expression matching with it of experiments, that experiments if it is valid, then whatever the mechanism we have assumed, that is correct, otherwise we go for the other mechanism. It is a trial and error method. Here also the people do the same way. They will assume the different initiation, propagation and termination steps. Based on those steps they conduct the experiment, they will get one rate expression. They will conduct experiments that of experimental rate and this model rate is getting matched, then whatever the mechanism they have assumed, that is correct. Everything goes by the trial and error method, and both the steps are assume mechanism and find the rate expression and match with experiments. These are the only three steps are there. And to get this rate expression, we have to apply one hypothesis, which is called pseudo steady state hypothesis. Whether it is a non-chain mechanism or chain mechanism, we have to apply this hypothesis. What is this hypothesis? You can see the intermediates here, right? HR dot here, Br dot here, here A dot, that means activated azomethane molecules. These are called intermediates. That means during the reaction the intermediates form and immediately it will consume, but on and whole there is no formation of intermediate. That means if I conduct reaction for 10 minutes, in this 10 minutes you won't find a formation of molecule, you won't see intermediate in, because intermediate are so fast in getting reacted, you can't able to find the molecules of intermediate. That is why if you can't able to find the molecules of intermediate, the net rate of formation of intermediate is equal to 0. So this is nothing but pseudo steady state hypothesis. That means we know intermediates will form and intermediates will consume, but there is no net formation. That means you can't able to find those molecules during that reaction. There is no net formation of intermediates. That is why it is called pseudo steady state hypothesis. In this hypothesis, we find that if R is my A gives rise to R, R gives rise to B. If R is my intermediate, then RR, that is the rate of formation of intermediate, that is nothing but dC by dt. Formation is always positive, that is why there is no minus symbol here, minus. So R rate of formation, that is dCAR by dt, is nothing but formation minus decomposition equal to 0. Okay, we have to make equal to 0. That means there are few reactions intermediate will form, there are few reaction intermediate will consume. Example, in this reaction intermediate is getting consumed, in this reaction intermediate is getting formed. So water formation minus consumption, at every time the net rate is 0. That means you can't able to find the molecule of intermediate in the reaction. That is why net formation minus decomposition is equal to 0. That means even though some things are forming, because the other things, some reactions is trying to form intermediate, another reactions are trying to consume the intermediate. So positive minus negative is equal to 0. That is nothing but pseudo steady state hypothesis. So whether it is a non-chain mechanisms or chain reactions, you have to apply the hypothesis to get this rate expressions. We will see in my another lecture, I will get the rate expression of formation of minus azomethane decomposition, which is nothing but a nitrogen formation or ethane formation, K1 K3 into Ca square divided by K3 plus K2 into Ca. So let us wait my next lecture, I will derive this and I will show you. Okay, thanks for listening to the lecture. We will come back with a new lecture.